Hello and welcome to the next episode of 3D and 30. Today we're going to be talking about above and beyond the innovations in aerospace in AM or additive manufacturing, if you're not familiar with what AM refers to. On this episode of 3D and 30, we're going to welcome an industry dino, or as we refer to him, an industry dinosaur. This is Matt Donovan, Chief Engineer at Starhagen. If you don't know what a dinosaur is, or a dino, is an award they give at AMUG, and it's for leaders in the industry, people who have contributed a lot to the AM industry. And we're going to find out a little bit more about that later on in the show. Matt has a long history in the AM community, and that's part of why he has the Dino Award. Looking at the transformation of this industry over the last 20 years. And so that I always find this fascinating. This is a technology that at Velo 3D evolves weekly. We can do things a month from now that we can't do things today. And this is kind of a common thing. And for the whole industry, it's been evolving very quickly. So seeing that transition is pretty awesome. We're also going to dive into Matt's career progression, look at some of the challenges in his early days, see where he thinks the future of the industry is going. We're going to look at Starhagen, that's his company where he is currently, and look at some of their successes in aerospace and defense. So with no further ado, I'll bring Matt on. Also, as a reminder to our audience, this is a live show. We'd love to hear from you, and we will get to your questions as quickly as we can. There can be a delay between when you submit a question and when we see it, so please allow for that. And also, sometimes if we're in just a really riveting conversation, we do get sucked into that, so just give us time. So Matt, welcome to the show. Can you tell us a little bit about your background?
Hi, Mike. Thanks a lot. Appreciate the invite. My background is primarily, I would say, mostly in aerospace. I've been working in aerospace since 1998. Started a small company that was making fuel injectors for jet engines and hot section components for that. And I still consider myself a manufacturing engineer at heart, but I've kind of twisted that position quite a bit as over the years as we've evolved a bunch of technologies. And so I worked in standard manufacturing for, until about 2006. And then I transferred into our research lab. And at that time, it was company was Goodrich. And I started doing the advanced manufacturing, and we were challenged with inventing new technologies and new solutions to, manufacturing problems for really making advanced fuel injectors and hot section components for jet engines. And that's when I was introduced to metal additive manufacturing back when I was working with Greg Morris and his team at Morris Technologies. We had some really great successes early on, and I'm very proud of the work that we did. We invented a whole slew of different types of innovations for fuel injectors as well as for the additive industry. And I stayed there until 2017. And for a couple of years, I was at a company called Earlicon, doing the same thing, helping customers build parts. And then I went to Jabil and got some experience doing medical parts as well as aerospace components. So in addition to parts that we were making for the Apache helicopter, one of our other facilities, we were making spinal cages and knee replacements. So got to work on a lot of very fun fields. And then I stepped away from Jabil, and about a year or so ago, just under a year ago, I started here at Starhagen, and I'm leading, all of the additive effort here at Starhagen. So when I started August of the last year, we just had an empty room, and I think we'll show a picture in a little bit of what that room looks like now. I was really proud. One of the things I was, for me, what I feel was a really significant accomplishment was 2 months to the day of after I started. And as I said, it was a completely empty room when I started here. We installed our Velo system, and we actually shipped our first 3 parts for a second stage rocket engine within 2 months. So that was, to some that might not sound like a lot, but for me, it was a great accomplishment, I feel.
So that And you're kind of highlighting how quickly that turnaround time was. What have you experienced in the past for, like, you get a system, it shows up on your floor. How long might it take in previous roles to be shipping for revenue?
What I've generally told people, if they're getting into it from the get go, starting from scratch, I tell them plan on nothing for the first year.
Wow.
Realistically, I think it can be done faster depending on who you bring on for talent, what you have for funding and resources. And there is an awful lot of facilities and infrastructure work that has to be done. There's a lot of material development that has to be done for aerospace. So it's an extensive body of work that there's a whole lot of things that most people just don't understand or see the behind the scenes, all the dirty work that you have to do to get to a point to where you're ready to make parts.
And I didn't just put it together like a second ago, but the companies that you mentioned previously, while they're all sort of innovators and high tech companies, they're like Ehrlichen. The first time I encountered them was in solar, but then I found out how much business they did in fabrics or making machines for fabrics. I think it is. G obviously does a ton of different things. You mentioned Jabil. They make just anything for
Yep.
anyone. And additive in each of those cases, probably not the primary revenue. I think I wouldn't go out on a limb saying it's not the primary revenue contributor for any of those companies. But now you're in Starhagen, where now how would you see AM fitting into Starhagen's business model?
Um, you know, at first blush, a lot of people probably wouldn't see a connection there. Um, so before I started here at Starhagen, um, we traditionally just manufactured components for aircraft interiors.
Yeah,
So pretty much every part that uh, you see on an aircraft seat bench, the fold out trays, the struts. Yeah, so that's a great example of an assembly that's up. We make everything there but the seats and the seat belts themselves. So all the connectors, all the arms, the hinges, the trays, including the plastic parts. We do vacuum forming plastic here as well. So we make all of that here at Starhagen. Now that we're getting into additive, we're really trying to step up our game, really get into the much more challenging, the harder parts of aerospace, of the hot section, the exotic metals. Um, so I mean, mostly so far the parts that we've made here in the 11 months that I've been here, we've made a number of rocket engine parts, helicopter gearboxes, heat exchangers, um, missile fins, and some other things I can't talk about.
now, yeah, we mentioned before aerospace and defense, not a very well known industry for being open and transparent with what they're making. um, but those are very different components. Like you look at uh, the seats, kind of traditional business, and now you're getting into hot sections, obviously functional components, engine components. Well, have you seen a difference in delivering those parts to customers? Are there different people that you're talking to? How would you describe kind of the business relationship with those?
It's definitely a different working relationship, working with these aerospace, the big aerospace companies or the rocket companies and what have you, versus I would say our legacy customer base,
Mhm.
for the conventional, just milled tubes and struts and arms and drink trays and things like that. They're Frankly, they're radically different animals.
Yeah,
They deal in different quantities. Um, and frankly, one of the challenges that I'm working with our shop to bring online is most additive parts are completely different than conventional manufactured parts. And a lot of that has to be worked through with. So we've got a good machine shop out here. We're fully 5-axis AS9100 qualified machine shop, and we have some very talented machinists. But if you haven't encountered the additive parts, you have to kind of change your way of thinking of how am I going to make this part? How am I going to machine it? Because frankly, a lot of the parts that are designed aren't designed to be able to be machined. Um, but the nice thing about working here, we're a small, very lean organization, and I work very closely with our subtractive machining leads. And every build that comes up, everything we quote, we talk in depth about how do we want to build this? How am I going to hold on to it? What tooling
Mhm.
are we going to need? It's just a completely different mindset that most people are not prepared for.
So one of the my questions, and you're probably the right person to ask this, is AM for a while it has maybe been the smaller contributor in terms of metal manufacturing, and a lot of the parts that people see in the real world are marketing samples. They're parts that don't necessarily go through a lot of these post processing steps. And have you seen that engineers are thinking about the post processing in their approaches, thinking about fixturing, thinking about hold to hold on to the part, or is that something that you're consulting with them on to kind of bring them up to speed?
I would say much more the latter.
Yeah.
Frankly, and metal AM is very challenging, and most people don't understand the back end infrastructure that you need. Like you're talking about the post processing, so like heat treatment, stress relieving, hipping, that's hot isostatic pressing, and EDMs, electrical discharge machining to separate parts from the build plates. You need furnaces, you need EDMs, you need people with metallurgy experience, you need welding experience. Um, Actually, I've given a couple talks at trade shows like Rapid um, and FabTech, actually talking people out of metal AM because machine shops, um, frankly, they see the ooh ah factor. They see these really cool parts, and frankly, sometimes maybe some sales reps might be painting a rosier picture of how easy it is than than it really is. Well, frankly, what I tell people when I was giving these talks, when people ask, how much is this really going to cost? What do I really need? Because they just see the machine cost, they don't see all the other infrastructure. And frankly, what I tell people is take the cost of the machine that you're planning on buying and multiply that by 5, and that's probably the amount of investment you're going to need to get fully self-supported, to get fully operational and qualified with test bars and metallurgical data and staff that you need to hire and inspection equipment. It it's it's a pretty steep learning curve, and it's not very forgiving.
Yeah, I've got one more observation, and I just kind of want to bounce it off you, and then we'll go to some questions here. We got a question from Ramsey that looks pretty good. Um, I, in our past at Velo 3D, like if you look at additive parts, you see a lot of brackets. You see topologically optimized, generative design,
Mhm.
whatever you want to say, brackets. And when we went through all of our sales processes, we didn't find a lot of value in making brackets. We found kind of what you're mentioning: injectors, rocket engines, shrouded impellers, turbine components. Like these are they're hot. A fluid is flowing through this part, and the fluid flow that goes through that part is critical to the operation of the whole assembly. Those are parts where we feel like we've got a line of sight into, and I don't think that AM is closely tied to that type of part as I would expect. But again, I'm seeing a lot of the marketing things. So what is your thought on that? Are we marketing this in the right way and getting out the right kind of parts?
Um, so yes and no, frankly.
Mhm.
So people talk about brackets, but when I was working on some brackets for a customer, you know, Airbus had over 1,000 brackets of a certain type that they use on one of their planes, and um, very common when I was working in the hot section areas. Uh, Pounds cost dollars,
Yeah.
so you know everything you can do to shave weight off of a part. Yeah, even if a bracket might be a little bit more expensive, if you can shave a significant amount of weight over it, when you've got 1,000 of those on a plane, that adds up to a lot of fuel savings. So, yes, there's some really fancy brackets out there, and GE had a design challenge on that a couple of years back that was really fun. And I'm seeing literally hundreds of different types of brackets. But it depends on what the need of the customer is. Like
Mhm.
in aerospace, weight means more than anything. Weight and performance usually mean more than cost. Um, where I see a whole lot of opportunities, frankly, is going to be casting replacements as we get these bigger machines that can do, aluminum castings. Actually, part I'm working on right now for an aerospace customer is investigating, can I make a comparable quality to a legacy casting that they've got? And I feel very confident that we'll be able to do that and make it, in fact, much better. But it's not just the casting side of it; it's the lead time. So when you're developing these new next gen air dominance fighters, for example, there's going to be a lot of complex parts. You can't wait 18 months to 2 years to get your first part. You need them now. So, and additive permits us to make parts very fast. We get, a lot of people have heard the mantra, you get to fail faster. So you can iterate and learn quickly and change your designs. And that was one of the early areas that we saw opportunity in when I was at previous places. But I see it even more and more every day.
Now, we do have a question from Ramsey. I hope I'm getting your name right. Do we need to change or update the PLM steps as generative design and additive manufacturing are already changing the common product development process? What are your thoughts on that?
So I'm assuming we're referring to product lifecycle management as PLM.
Assume so.
Um,
Yeah.
so there are a lot of PLM challenges, frankly. For me, PLM systems, you can make it work with additive, but it is every place that I've worked at has had different challenges with their PLM systems, both managing the models and the design configurations. Over the years, it's real easy to fall into a trap of making the wrong configuration of a part, and you just threw away maybe $30,000 by making the wrong configuration if you don't have good PLM control. But also, on the ERP side as well, a lot of these systems like SAP, JD Edwards, Job Boss, whatever, they really struggle with how to incorporate um, this completely different way of managing things. Because they're used to buying certified bar stock, and I need 6 inches for this part, and we just cut off a chunk and off you go. um, you know Create a traveler and what have you, versus here I'm taking a metal plate and I'm taking some powder, and voila, here's a part. And they're like, well, how do I manage that?
Yeah, no, it's interesting. I also think when you decide on your manufacturing solution, depending on how your company has done PLM in the past, could happen very early versus pushing for optimization and then looking for a manufacturing solution. We've done a number of case studies with customers where the order in which you do that can open the door to additive or it can shut the door for additive. And so it's kind of
Yeah,
interesting to see.
I've seen a lot of parts that people are, well, frankly, they get sticker shock when they think they've got a great part for additive. But frankly, if you're making it a high volume casting and you don't have supply chain problems, it's probably not going to be cost competitive if it's, say, a little $30 widget that you can cast by the thousands. Now, if
Yeah.
it's a big housing that you have high mix and low volume, it probably is a good opportunity. I would say, when I was in working on fuel injectors, there was a number of great opportunities for particularly the land-based engines as we were learning and building our qualifications for the aero side. Um, there's a whole lot of very low volume, high mix parts that are legacy parts that have been troublesome to make over the years, and additive can be close to a magic wand for that. It's really, there are a lot of opportunities there.
Yeah, it's probably a good segue. What capabilities does Starhagen have specifically, like in terms of the printer size or the alloys that you have access to?
So we have, on the additive side, we have two Velo sapphires, standard sapphires. The one that was on the right side is running Inconel 625, and the one on the left is running aluminum F357. I believe to date we're the only shop that's running a Velo with aluminum in it here in the U.S. And so it's a lot of fun to work with. I get to make some really cool parts on it, and they look great. And I love particularly the part that I was just working on a few minutes ago before this call. I would not be able to make on another printer, but you know what? I stuck it in here, and I'm like, I don't have to worry about my overhang angles here. It's just gonna just drop it in and go. So um, in that respect, it's a lot of fun to work with.
And you mentioned the Inconel 625. I know a lot of customers are using the 718, but 625 has some interesting characteristics that make it kind of advantageous compared to 718 in some cases.
I would very much agree with that. So a lot of our space customers, particularly, they prefer 625 because it's much more resistant to hydrogen problems. And the other thing is there's far less heat treating that you do for 625. I would say people typically use 625 more for ductility and corrosion resistance versus 718. It is a little bit stronger, but it takes 4 heat treat cycles to get to that strength. And it's you're talking 27 hours of heat treating on a part, so it does add substantial cost to it.
Yeah, and that's definitely something that should not be an afterthought when you're looking at it. If you got to look at your post processing, your heat treating, your machining, all of that.
Mm-hmm.
It's got to be done up front. So these alloys kind of give you access to maybe some different customers. To the degree that can you give us a couple success stories with customers?
So we work with a local company, Corvid Technologies, and they do all kinds of really innovative solutions for, I've worked with them in a past life on warheads and missiles and other defense related systems. Earlier this year, we made some missile fins for them that are in development for a new type of deployable wing on a missile. And that was really fun. It used my entire build volume. So they were really fun to make. I wish I could show you pictures of it, but it's an ITAR part. I can't show you.
Yeah.
Sorry. Another one, like I said, those rocket stage 2 rocket engine parts that we made for a commercial space customer, right when I started here, those were a huge success, and I'm very proud of them. Right now, we're making some manifolds for a Navy submarine that is, you wouldn't know it's a manifold to look at it because it's all lattice and it's very, very complex, but it builds great, and we're very optimistic that it's going to provide superior mechanical properties over the legacy system.
So, I mean, fins don't jump to the forefront when I think about an additive part. What is it about additive and the fin? How do those go together? Are you allowed to talk about that a little bit?
At a high level, I would say in this particular case, they were working on a new type of deployment for what I could say is that so missiles frequently you see hanging off the wing of a plane have the fins in place and they're fixed. These were for a tube launch type design, so they had to be deployable, so they had to retract and extend as they were fired.
Okay. Yeah, we have to be really vague in these conversations a lot of times. That's pretty awesome. I know from some of the parts that we have been able to talk about in the past, these rocket engines are just amazing. Like you're packing in so much
Mm-hmm.
now. You've got injectors built in, or conformal, or not conformal, regenerative cooling
Yep.
built in. and it's all printed in one go. Or what have you seen in terms of the functionality that people are putting into these parts that maybe surprises you?
Um, Boy, so a great example is I'm good friends with a number of folks over at SpaceX and have worked with them in the past, and we'll probably be hopefully working with them more now here at Starhagen. But they're a really good example of building all that functionality into a part and thinking, what can we do with this? What parts can we incorporate into this and uh, reduce the supply chain for it. The other one was Relativity Space that just launched a 85% additive rocket. That blew my mind. That they did DED, direct energy deposition, on such a massive scale.
Yeah.
It really blew me away. But I mean, I love the innovation and I love the design freedom that we get. And working with so many diverse customers, I get to learn from them too, just from their designs. I learn like, oh, hey, that's a really neat application of a technique. And I can translate that into helping others, with their designs as well to um, help them incorporate features that they previously wouldn't have thought of.
So we have a kind of a question here, maybe a lead for you. Someone's asking, I need aluminum frames for my solar inventions. Think about tracking high winds, water loads. Would
Mhm.
there be components in there that you think would be additive? And obviously, you have traditional manufacturing solutions as well, so you'd probably be able to meet this customer's requirement either way.
I would think so, and yeah, and the gentleman or sorry, it's Charisse, I think it is. Yes, please reach out to me on LinkedIn, and I'll be happy to help.
Awesome. And there's a question about the PLM systems. Can you expand on which systems you're referring to when you talk about digital files and configuration management?
So the with regard to PLM systems, I've used Product Center and Siemens NX or Siemens. Well, we used Siemens NX with the PLM bolt-ons. Some of the challenges with it are, so design engineers like to make different configurations. They'll have tabular driven components. So, you have a whole family of different dash numbers. It's real easy if you're not very meticulous about both your file naming convention, but also your file control and uh, how you work back from the end design files backwards towards your additive file. It's very easy to slip up and basically get the wrong file and get the wrong configuration.
Okay, yeah, that sounds complex. I notice we're getting close to 30 minutes. If you, we probably have time for maybe one or two more questions from the audience. But I did ask some of, did want to ask one question. What have you seen over the last 20 years that surprised you the most, both in you didn't think the industry would do it, but it did, and maybe on the other side of that is, the industry really should have done something, and it still needs to do it.
Um, well, I'll take your second one first. I still feel that we don't have sufficient onboard in situ monitoring for defect detection. There's a lot of people working on it, and there's some good developments on it, but I don't see a whole lot of production ready versions that are out there on many machines. With the Velo system we've got, I love the access to the sensors that I've got and the Assure system and all that. It's way better than anything I've worked with in the past. So there's that. Um, as far as what I've seen that I never would have thought about, it's a tough call.
Or maybe some of
Frankly,
your work
I would
on
say,
the codes and compliances or ASTM work.
I'm sorry.
You mentioned some of your work that you did on kind of getting standardization in the industry.
Yes, we've
Yeah.
made a lot of progress over the last 10, 12 years. I started with ASTM back in 2010 and helped create a number of the standards, but more ASTM or AMS standards are definitely desirable. There's some really good ones that have been coming out by AMS recently, particularly AMS 7000 series, the 7000 through 7003 for Inconel. I use those day in and day out, and 7532 as well. So those are great. Frankly, if I got to pick one thing for something I never would have seen predicted 20 years ago, I would have said that relativity space rocket, the 85%
Yeah.
additive rocket. I would not have. I wouldn't have seen that coming.
Yeah, the whole space race in general is just amazing how quickly it's been moving forward and how closely it's working with additive. And I don't think those are an accident that those are correlated the way they are. So kind of a finishing topic, but where do you think the industry is going to go in the next 5 to 10 years? What do you, if you had to look into a crystal ball, what do you think we have coming down the pipeline?
Well, I see a whole lot of evolution in drones. The whole situation in Ukraine has just seen, necessity demands innovation, and I can't speak to some of the innovations that I've seen that they're doing, or that some of our customers are using to support them, but it's incredibly impressive. It's also, frankly, a little bit scary. What I think what will, because I do see drones being a particular challenging area, both in terms of military and just frankly civil aviation, and the danger that irresponsible use of it could do. And frankly, there's a whole lot of really good printers. Like, I've got one behind me. It's a bamboo that, I could probably make almost an entire drone with that. And I know people who are doing exactly that. So I see that as being one of the challenges. But, I see way more evolution in big parts and lightweighted parts. Actually, I see probable automotive applications, getting into the high volume components, that, frankly, the value proposition wasn't there a few years ago, but I see us with these newer, bigger systems with lots of lasers. We are going to be able to really crank out parts at a very high rate.
Yeah, I think, and if you're interested in Velo 3D's experience in automotive, we do have a 3D and 30 on that. And so we can put a link to that in the bottom. But we are kind of closed up on time. I do want to thank our audience for attending. You've been great. I love the questions and the comments. Matt, you have a lot of fans out there. A lot of people are saying hi and hello. So, make sure to give them a thumbs up when you can. And Matt, thank you for being on the show. I know we had some topics we weren't able to get to, but I love deep diving into some of your experience and your background. I love bouncing off ideas to see what your perspective is. Fantastic resource. So thank you very much for being on the show.
Thank you. This is a lot of fun. I'll love to do it again, or talk offline with anybody who's interested or has questions. That's what I love about our industry is we're very small and tight knit, and my competitors call me for help. I call them for help, and we all help each other out. We're competitors, but we all want to see the technology succeed. And I love solving problems for customers. So it's that's really why I do what I do.
Awesome. Well, thank you, Matt, and that's a wrap for our show today.
Thanks a lot, Mike.